Hello everyone, you are welcome to the GMAETS41's mathematics class. I'm very glad to meet you once again today and I hope you are doing fine. So in our class today, I'll be introducing you to basic arithmetics. Before now, in our last class, we concluded numbers and numeration where I taught you rounding off. Part 6 of that numbers and numeration. And so we are moving a step further into another aspect of mathematics. Another secret foundation of mathematics. Yes, part 2 of it. Part 2 of the secret foundation of mathematics. Basic arithmetics. When we talk about arithmetics, generally, what does it mean? What are our interests? Arithmetics generally deals with the basic operations that we carry out in numbers. And when we talk about the basic operations, what do we mean? Addition, subtraction, multiplication, and division. 4 of them are the basic mathematics operations that we carry out on 2 or more numbers. And of course, that is what this basic arithmetic is going to teach you. Yeah, we have other forms of operations like squares and square roots. We're going to discuss those ones in subsequent classes. In this class, I'll be taking you through part 1 of basic arithmetics, addition. As we move on, we'll look at part 2, subtraction, then comes part 3, multiplication, and of course, we'll conclude that with part 4, which will be division of numbers. As I teach you addition of numbers, please, let me say this now because of how important it is. You can start preparing ahead for multiplication. And what will help you? Learn your multiplication table. So if you're still having any challenge in multiplication table, 2 times 1, 2, 2 times 2, 4, 2 times 3, 6, 2 times 4, 8, down to 12 times 12, 144. If you still have any challenge there, I advise you to start practicing it. You can give yourself this target. Perhaps before you go to bed, let that be the last thing you say, after which you say prayers and sleep. Why not tell yourself, okay, every day I am going to learn a particular multiplication table. Start now. Start now. I have always said, multiplication is the boat you need to cross the mathematics bridge. Hello, friends. Join me as I take you through the journey of addition. We're not going to waste time on this part 1 because it's nothing too much. So I start by asking, what is addition? Whenever you hear the word addition, what comes to your mind? On the board here, I have this brief explanation to read, okay? Just to give you an idea into what addition is all about. And addition simply means bringing 2 or more things together to form one thing. Most times, these things we bring together, they are numbers, all right, when we deal with them in mathematics. But of course, in your everyday life, in one way or the other, you do addition. Is that okay? Now, let us think about this. Imagine that I give you 2 oranges, and then think about your friend giving you 1 more orange. If you put these oranges together, 2 oranges from me, 1 from your friend. Now, putting them together, you count. You will get how many oranges? 3. 1, 2, and 3. So these are the 3 oranges. Now, you notice that when you put these oranges together, you would get more oranges. Now, when you add 2 or more things together, of course, these things must be the same. You cannot be talking about adding orange to pineapple. These 2 are different fruits, all right? So if you're talking about adding something together to get one thing, those things must be the same. So you can add pens together, you can add other things together. They must be the same. That's what I'm trying to say. This is very important because, again, as we move on in the study of mathematics, you will learn about what we call like terms. Don't worry, we'll come to all of those. Let's move straight on to what we are talking about. When you add two or more things, the answer you are going to get, that answer will be greater. That answer will be bigger. It will be larger than any one of the things you added. In the case where we got 3 oranges, I gave you 2 oranges, your friend gave you 1 orange, put together, you now have 3 oranges. The 3 oranges you have is greater than the number of oranges that I gave to you. And it's also greater than the number of orange that your friend gave to you. You now have 3 oranges. I gave you 2. You notice that 3 is greater than 2. Your friend gave you 1 orange. You have 3 oranges altogether. That 3 is greater than the 1 orange your friend gave to you. So always remember this. Anytime you add 2 or more things, your answer will always be greater than, will always be bigger than any of the things you added. And of course, like I said, addition, just bringing things together. Alright? Now, we have the secret here on the board. Of course, you know how we do that always. GMAETS41 always gives you the secrets, the principles, the guidelines, things you should be thinking about whenever you are handling calculation problems. And once you're able to follow up these secrets, you won't have problems in that thing that you're studying. And so here on the board, I'm going to teach you 3 secrets, things you need to know when doing addition. I'll be very fast in them, so we can move on straight to the solving of questions. So we now have our very first secrets. Secret number 1 is based on place values. Place value again? Yes. When I taught you place values under the secret foundation of mathematics part 1, numbers and numeration, in our past classes, I told you how important place values is to the study of mathematics. And you are seeing how it keeps going like a chain, linked on and on and on. Now, you need to arrange the numbers given to you neatly under their correct place values when you want to do addition. Very important. And if you take your mind back, we have whole numbers whose place value starts from units and then it moves to the left, increasing to tens, hundreds, thousand, 10,000, 100,000, million. I taught you up to trillion, remember, right? That's good. Then I also taught you about decimal numbers. For decimal numbers, the place value starts from tens and then it moves to hundreds. It keeps decreasing to thousands, 10,000s. So you're moving towards the right. Starting from the decimal point, you move towards the right. And the place values will be what? Reducing. I've taught you all of those. So if you still have any problem with them, please go back to the video lesson. You can scroll up and then you search for the video lesson on place value in this Telegram channel. And of course, watch the video on it to refresh your mind on place values and how to arrange numbers under them. You need that a lot when dealing with basic arithmetics. Okay, then secret number 2. Whenever you add 2 or more digits and the answer it gives to you, let us assume you come to a place value, you are now doing the addition of the numbers you have there. When you are done adding these digits, the answer it gives to you, if that answer is less than 10, let us assume you got either 9 or 8 or 7, 6, 5, 4, 3, 2, 1 or 0. Because this answer you got is less than 10. You are expected to record. You are expected to record that result directly under the place value you are working on. And then secret number 3. What if you are doing the addition and under a particular place value, when you add up the digits, the answer you got is 10 or greater than 10, that is above 10. What do? Do you record the 2-digit numbers? Because if you get 10 or any number greater than 10, you are operating in tens now, 2-digit numbers, which is the highest you can get under any place value. Now if you get something like that, do you record the 2 digits under that place value? The answer is no. So what are you expected to do? There is a real mathematics that explains that, but I won't go into that for now. In one of our fun classes, I will show you something about how we came about what I'm going to tell you to do now in that case. Alright, we get that idea from number-based system actually when doing addition in other bases. Okay, so this is what you're going to do. If you get a 2-digit result, record the unit place value and then move the tens place value to the next higher place value on your left hand side. I'll give you an example. Let us assume that you add up a particular number, that is numbers under a particular place value, and the answer I gave to you is 12. Now if you get that 12 is a two-digit number. So what do? Simply record the unit place value. In 12, the unit place value is 2. Is that not so? So you are going to record this one down. You record this, and then you move this one to the next higher place value on your left-hand side. You add this tens place value to the next higher place value, and then continue your what? Addition, as the case might be. So that is what you do. Whenever you do your addition and you get up to two-digit number as your answer under any place value. Having explained this place, I'd like to tell you to take note of this. All the calculations we're going to do under this basic arithmetics, under addition, subtraction, multiplication, and division are going to be in base 10 number. I'm saying this, that all these calculations you're going to learn under basic arithmetics are going to be in base 10 because we also have this part of mathematics that we call number-based system, where we can carry out our operations or basic arithmetics in any other place values, like in any other base, like base 2, base 3, base 4, base 5, another basis. But the ones we're going to focus under these basic arithmetics are going to be base 10 numbers only. And now we are set to solve questions on addition. I hope you're ready, right? So let us move on to our very first question. Add 576,900 and 702,513. This question number 1 comes under addition of whole numbers. Because I'm also going to teach you addition of decimal numbers. How do we solve this? Like I said, it's a simple one. The first thing is to write out these numbers according to their place values. I'm going to solve this first question showing their place values. But out of these two numbers, which one is greater? If you look at both of them are in hundreds of thousands. Alright? This is 576,000. This is 702,000. Now if you look at their 100,000 digits, their 100,000 digits, this is 5, this is 7. I think that of 7 is greater, is that not so? Alright, so we move on. 100,000 is the highest place value, so you get down to tens of thousand, get down to 1,000. We have 100, tens, and what? Unit. I always like writing the bigger number first. It is not a law, it is not a rule. But I like writing the bigger one first so that the smaller one will come under. Is that okay? So I'll move on by writing 702,513. I've told you why this is greater. Both of them are in hundreds of thousands. Now if you pick their highest place value digits, this is 5, this is 7. And both of them are 100,000 in place value. So this 7 is greater. I'll fill up this digit first under this place value. I like starting with the unit side, so 3 will come here. 1, we have 5, 2, 0, and 7. Then I'm going to write my plus sign. Very important, put it. If you don't show the plus sign, you will lose mark. Because I will just assume I don't know what you are doing, which basic arithmetic you are doing. Whether it is addition or subtraction, multiplication or division, I will not know. So always remember to put the operation you are using. Plus, this is what we use, addition. Okay, now I will come and fill up this 576,900 under these place values as well too. Starting, we have 0 under unit, the next 0 under tens, 9 under 100, 6 will come under 1,000, 7 under tens of 1,000, and 5 under hundreds of 1,000. Good. What a neat arrangement. I've arranged this number under their place value. Secret number 1 is done. This is the time I will now start adding. So I just drew a line here to separate these numbers I'm adding from the answers I'm going to get. So I will start adding, starting from the smallest place value. And of course, the smallest place value for these whole numbers is units. And so going by that, we'll come to unit. 3 plus 0 will give us 3. 3 is less than 10, so you record it directly. Come to tens. 1 plus 0 is 1. 1 is less than 10, so you again record it directly under the tens place value. Come to 100. 5 plus 9. 5 plus 9 is going to give us 14. Alright, 14. Now let me show you something. 14, is it a one-digit number or a two-digit number? Correct. 14 is 2-digit number. So record this one down, which is 4. Record this 4. And then you will carry over, move this one to the next place value. I am tempted to tell you why it is this 4 we record, but I'm just holding myself down and saying, no, don't bother these people at this point in time yet. Anyway, don't worry, let's just do that in our fun class. There is actually a division that helps us to know that it is 4 we are going to record. That 4 is actually a remainder. That 1 is a whole number that we are moving over to the next place value. But permit me to say, I'm going to teach you that in our fun class, okay? Let's just move on for now. Know that you're going to record the unit digit and move the tens digit to the next higher place value. So coming to this 100, I'll record 4, and then I'll move 1 to the 1000 place value. Let me attach the 1 here, okay? So look at that. And that 1, I will add it to these 2. If you add 1 to 2, you get 3. Add 3 to 6, you get 9. 9 is less than 10, so you would write it down. Good. Come to tens of thousands. 0 plus 7 would give us 7. 7 is less than 10, you bring it down. And then finally, under hundreds of thousands, we have 7 plus 5. 7 plus 5 is 12. So once again, it's a 2-digit number. You're going to record this one. So let me write R, and then you move this to the next higher place value. So I'm going to record 2 here, and then move 1 to the next higher place value. Let me just come and write it here, okay? I'll use black marker to write it. I'll move 1 to just a place like this. Now that place value that I moved 1 to is not showing there. It is an invisible place value. Of course, after hundreds of thousands, the next place value you made is million. Is that not so? Million, which means we are moving that 1 to the million place value. And of course, with the 1 here, there is nothing to add it up to. There is nothing to add this 1 to. So what do? Simply bring down the 1. Simply bring down the 1. So you see, it is as if I just recorded 12 directly, because this is the last place value. But you won't come and write the 12 together under this 100 place. You don't do that. Write your 2, shift your hand, and then write 1 under and assume a supposed place value, which is invisible as said. And this is our answer. The answer here, how do you pronounce these digits? Of course, you separate into 3, 3, put a comma, 1, 2, 3, put your comma. So this is 1,279,413. And that's the answer. I'm done with question number 1. Can I conclude therefore? 576,900 plus 702,513. Right, the answer is equal to 1,279,000 and then 413. So this is the solution to question number 1, and we'll be moving on to question number 2. In question number 2, we are to evaluate 999,988 plus 410,821. You see, I took my time to explain everything, every detail in this question number 1. Question number 2, I'll be fast in solving it. Alright, now if you look at this, the highest place value is hundreds of thousands once again. So I'm going to write them out. Tens of thousand, hundred, tens, and unit. Then of course I'll fix up the numbers. The highest out of these 2 is 999,000. So 988. Starting with the units, I have this. Then I'll fill up as usual. And then plus, I'm adding 410,821. So 1. Now this is what we're going to get, and then simply I will proceed to add them, starting with units. 8 plus 1 is 9, you can record that down. 8 plus 2 is 10. You can't record 10, there is 2-digit number. So you record the unit digit 0 and move 1 over to the 100 place value. So the one I'm moving to the 100 place value, I'm going to write it here for you to see. Now 1 plus 9 will give us 10. 10 plus 8 is equal to 18. 2-digit number, so you record 8, which of course is going to be the remainder there, don't worry. Now record 8 and then move 1 to the next place value. We have this, I will touch it here. Okay, I'll add it to that 1000 number, which is 9. 9 added to this one I moved to it will give us 10. Again, you cannot record 10. Just record 0 and move 1 once again to this tens of thousand place value. Add this one you moved to 9, you get 10. 10 plus 1 is equal to 11. Again, you record 1 and move 1 because 11 is a 2-digit number. Move 1 to this hundreds of thousands. Adding this to 9, you get 10. 10 plus 4 is equal to 14. That 14, you record 4, and then you move 1 again to the next higher place value, which of course is an invisible million place value. Then I am going to bring down that 1 directly because there's nothing to add it up to. And this is my answer, 1,410,809. Conclusion, therefore, 999,988. Added to 410,821. My answer is going to be 1,410,809. That's how simple we solve this question. We are going to conclude addition of whole numbers by looking at a word problem question. Is that okay? Question number 3. And now we have this third question. Okay, it's a word problem question. Word problem. In mathematics, when you hear word problem, it's a question given to you where we speak lots of grammars as much as possible. Then you will now put it into mathematics a statement, all right? And of course, solve whatever you're asked to solve. The question reads, in January, Chinwe spent 523,000 naira on importation. In February, she spent 90,120. And in March, she spent 8,995 naira. Alright, if she is expected to spend 2,018,421 from April to September, how much will she spend altogether? So if you look at this question, it's the amount of money that Chinwe will spend altogether from January down towards September. And the question gave us a breakdown of how she spent this money on a monthly basis. So how much will she spend altogether from that January to September? So that's what the question is all about. And it's a simple thing. We're talking about what she will spend altogether. You know, she's spending this. So you have to put all the money that she spends together, and then you get a total. Is that okay? Now, let us move on. If you look at the amount of money given here, I think the highest is the one spent from April to September, which is 2,018,421. I will solve this question without writing place values, because it's expected that this place values is already registered in your memory. Are you following? So you can play around with it. It's not compulsory that in all questions you must write out the place values and all the things. I told you right from when I taught you place values that the reason why I write them out is to help you understand how important place value is. So you learn it before it is too late. Now I will start with the highest number there, 2,018,421. 2,018,018, and then we have 421. Okay, when you're writing out the digits during addition, it's always good to give a little spacing between them. Don't write them too close like they are here, okay? So you don't go misplacing the digits. Alright, the next number that is bigger here is 523,000 naira, which of course I will record under this. I'll start with the unit 0, and then 0, 0. 3 will enter, 2 will follow, and then 5. This is 523,000. So you see the way I arrange them, right? Starting with units, so as to avoid making mistakes. And then the next one that is bigger is 90,120. Of course, it's bigger than this one. So I would enter that value here. 0 will come under units, 2 will come under tens. 1 under 100, 0 under 1,000, and 9 under tens of thousand. And then lastly, we have 8,995. 5 will be recorded under unit, 9 will enter tens, 9 will enter hundreds, and then 8 will enter 1,000. Good. These are the amount of money that Chinwe is expected to spend from January down to September. So I am going to add up this. Put my addition sign. Let us go. I'll be fast in doing that. 1 plus 0 plus 0 plus 5 will give us 6, because you just add 1 plus 5 directly. You get your 6 there, so 6 will be recorded. And then come to this 2 plus 0 plus 2 plus 9. 2 plus this 2, because plus 0 is still that 2, you know. Plus 2 here you get 4, plus 9 will give you 13. 4 plus 9 is 13. 2-digit numbers. You can't record that under this tens. Therefore, you record 3. In 13, the unit digit is 3. So record that unit digit, which is 3, and move the tens digit, which is a whole number, move it to the next higher place value on the left-hand side of the one you just finished with. Alright, 1 plus 4, you add up this, you get 5. 5 plus 0 is 5. 5 plus 1 is 6. 6 plus 9 will give us 15. Two-digit number once again. Do you record that 15 under this 100? No. Record the unit digit in 15, which is 5, and then move the tens digit, which is 1, to the next higher place value on the left-hand side. So here we have 1 plus 8, which is 9. 9 plus 3 is 12. 12 plus 0 is 12. Then 12 plus 8 will give us 20. 12 plus 8 is equal to 20. If you have 20, the unit digit is 0. The tens digit is 2. So record the unit digit, which is 0, and then move the tens digit to the next higher place value on the left-hand side. Look at that, 20. So this will be recorded down, right? Record 0, and then transfer this 2 to the next higher place value. Alright, we are moving on. Add up these 2 you moved to this place value. Add it to this 1, you get 3. 3 plus 2 is 5. 5 plus 9 is 14. Record 4, move 1 to the next higher place value in hundreds of thousands here. Add that 1 to this 0, you get 1. 1 plus 5 will give you 6. 6 is less than 10. So you record it down. It is just one digit number, you know. And then come to this next place value. What you have here is 2. There is nothing under it. So you simply bring it down, 2. And I am done with the addition. Conclusion, therefore, the total amount of money that Chinwe is expected to spend altogether will be equal to, let's find out. So we have 2 million, okay, let me write it out, 2640536. And this is 2,640,536 in Naira. So this is the amount of money that Chinwe will spend altogether, of course, from January down to September. Once again, 2,640,536 Naira. And I'm done successfully teaching you how to carry out addition of whole numbers. Next, we're going to see problems on how to add decimal numbers. If you have a question on that of these whole numbers, feel free to send the questions across, and of course, you get a response to that.